the observations made when I was looking at the abundances around 3 um, gave me some ideas for an algorithm to try to find a number with an abundance very close to 2. And so I just came up with the algorithm. Part of it is just arbitrary. Part of it was based on those observations. And I'm going to try to demonstrate how it works here manually. The algorithm itself is automated in order to produce many thousands of numbers and just keep track of which abundancy close to 2 is smaller than the previous found smallest one. But I'm going to try to demonstrate it manually. I'm just going to start out with some numbers. And I believe in the code, I start out with 12 prime components. And P, alpha, Q1, and beta 1, I can decide what they are, but they will just remain fixed throughout the process. It doesn't really matter what I set the betas to because they don't have a really big impact. I'm going to go ahead and change this beta to 2, just so we can say all the betas are not all 1. And start out with an abundant number. So this one that I have set up here with the 12 prime components going up to Q11 being 43. There it is, 2.88. So the algorithm starts by sorting the Qs. They're already sorted, but I'm going to sort them again only from well, the algorithm only sorts them from Q2 onward because the Q1 stays fixed. Then I increment Q2, and that again means changing it, swapping the 11 for the next highest prime number that's not used anywhere in this setup for n. So I'll hit this button, it'll do it for me. Okay, and so this we stay abundant with that. So the next step is to move to Q3. And so this, I could keep swapping out Q2 for higher and higher numbers, but based on the previous observation, that has a more and more negligible effect on this abundancy. So that's why I now switch to Q3. I'm going to swap it, and it's still abundant. So the algorithm, when that happens, I am going to sort the Qs again and start over. So I'm going to start over with Q2. I'm going to increment that, still abundant. So I'll move to Q3, it's still abundant. I will repeat this process, and you will see that eventually I'm not sure how many steps it'll take, but eventually it will drop below 2. So we're pretty close to 2 now. Okay, so changing increment to Q3 caused it to drop below to become deficient. So the algorithm will say undo that increment. So I'm going to put back the number I had before and then go on to Q4. So I'm going to increment Q4. That also made it go from abundant to deficient. So I'm going to undo that, then move to Q5, undo that. And so, based on what I observed from earlier, okay, so now this one, when I switched, when I incremented Q6, it stayed abundant. So the algorithm will say, sort the Qs and start over again with Q2. And what I didn't finish saying is that if you change a number, any of these Qs to a higher number, you'll get a certain amount of decrease in the abundance. But if you have an even higher prime number compared to the increment of the previous one, of the smaller one, compared to that, picking a higher number and changing it to an even higher number will have less effect. It will reduce the number by a lesser amount. Um, so whenever this drops, a certain amount is subtracted from this by changing one of the numbers that cause it to become deficient, and that's undone. And then we look to see if there's another number that will subtract a lesser amount from this, and maybe it will stay abundant. So that's the idea. So I'm now back to Q2 after sorting them. So I'm going to increment that, and it immediately went deficient. So I'll undo that, and I will continue. Okay, so I'm at the last one. I'm going to try to increment it, see what happens. And it went deficient. So if I get to the last one and this happens, what I'm going to do now is, I'll go ahead and undo it, don't really need to, but what I'm going to do now, what this indicates is an end of what I just call a cycle. And so the algorithm will be set up to do a fixed number of cycles. Sometimes I just do 10, sometimes I do as many as 500. But what just happened was a cycle ended. So now I'm going to start a new cycle. And what that mainly means is two things. One, I'm going to reset all of these numbers to what I had before, and then I'm going to add a new prime component. So I'm going to go ahead and reset my numbers. And I got to remember that I have beta 1 set to 2. So I'm going to repopulate this with just the minimal data, change my beta back to 2. And then you'll see whereas we had the 12 prime components before, now I'm going to add on one. So we have Q12 and it selected 47 for me. And then we start all over again. And every time it finds an abundancy that's closest to 2, then it will get logged in the log as being the smallest abundancy that it has found so far.